Can you give him?
Stations in the southeast. We should be there by evening. Those in kids are supposedly pretty fun.
Okay, sure. So, can you guess that we should do what for this problem? Exactly, a small example. But a small example on what? Mm, look, because t depends on this what, right? Instead of 100, we can consider what? Yes, 2, for example. If we have S1 and S2, then we can say what? The answer is what? Let me see. Why the 1, right? Yes, suppose we have 1 in both of them, right? Then let's see the condition. It says be finite sets of integers whose intersection is not empty, right? S1, S2 not empty for because the intersection is 1. For non-empty T, the size of the intersection of the sets in T is a multiple of numbers of sets in T. So T can have, if T has 2 elements, here we should have at least 2, right? Because if T is S1 and S2, it says what? The size of the intersection of the sets in T is a multiple of the numbers of sets in T. So it means that number of elements of T should divide S1 intersect S2. It is 2. So 2 should divide S1 intersect S2. What's your problem? Yes, yes. Our answer maybe look, if it is 100 here, it is 1. At least 1. Okay? Not exactly 1. So do you agree 2 should divide S1 intersect S2? Agreed. If T is S1 S2, 2 divides. If T is S1, then what divides what? So we don't need to check one elements. We don't have intersection. Also, one always divide, right? And it says non-empty, so we don't need to check T as a null set, right? So 2 should divide S1 intersect S2. So S1 and S2, S1 intersect S2 has at least 2 elements, right? Because it says it is not empty, intersection of all of them. So we have 2 elements, and it says, okay, how many? So if you consider this one as 2n, it is n, right? Then it says what's the least number of elements that are in at least one set? One set here. So answer is what for 2? For 2 is 2, right? For if 2n is 2, answer is 2. Now in next step we can check what? Yes, exactly. N1, if you have N2, then 2n is 4, right? It means that we have 4 subsets, S1, S2, S3, S4, right? Then what divides what? Yes, number of elements. Let me write this number of elements. 4 divides S1, number of elements in S1 intersect S2 intersect S3, S4. Then what? Yes, S1, S2, S3. We can also say S1, S2, S4. We can write S1, S3, S4. And last one is what? Exact. S2, S3, S4. Then what? Yes, we should write all 6 combinations, right? To S3, S4. And you don't need to write 1, right? Okay, because 1 is always divisor of S1, S2, S3, S4. Now for this one, we want to find the answer for 4. For 4 subsets, one hint or one to try on your own? Okay, sure, try. Why? Can you tell me your example is what?
3, 4.
So when they all have 1, 2, 3, 4. Okay, okay, let me write. 1, 2, 3, 4. 1, 2, 3, 4. Sorry, sorry, sorry. I should write like this. 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, and 4, 4, 4. Then what? You can say 5, 5, 5 for this part. Then for each three of them, you can say, for example, 6, 6, 6, like this. Then I think it would be greater than this because we have 4 choose 3 times 2, 8 plus 4, 12, right? 10, how 10? Uh, sorry, sorry, sorry. Why I said 5, 5, 5, 5? You say two elements, 5, 5, 5, 5, 6, 6, 6, right? Then you want to say 7, 7, 7, 8, 8, 8, right? Then 9, 9, 9, 10, 10, 10, and also 11, 11, 11, 12, 12, 12. So with your example, we reached 12, right? So you proved answer is at least 12. What? It says if you consider intersection of all of them, it should be multiple of 4. If you consider intersection of any 3 of them, number of elements should be multiple of 3, each 2 of them multiple of 2. What do you mean? So we should prove. We should find it is minimum of something. So we should consider answer between and at most what something at least what? One side is with example, one side is with proof, right? Which side is with example, which side is with proof, right side or left side is related to example. Exactly. The thing you are doing is example or proof, the thing you said here. So we can say answer is at most what? At most 12. Maybe. So let me tell you something. If you consider all of them, how many intersections are there? 4. If you consider 3 of them, because at least 2 of the sets, yes, at least 2 of the sets. No, 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 no. It means that, for example, look, this element is in 4 of them. We should count this. But for example, maybe one element, for example, 15, is only in this one. You shouldn't calculate that. Understood? And let me tell you something. S1, S2, S3 is 6. It's okay. S1, S2 is what? If we consider, it's 8. So it satisfies, right? So answer, these elements are in at least 2 of them, right? 3 or more. So you found 12, but now we want to prove that why answer is at least 12, right? Okay, want hint for this part or want to try on your own? Okay, sure. So, here, for example, these elements are in all of them, right? A1, 1, S1, 2, 3, 4. So, let's consider number of elements that are in all of them, A1, 2, 3, 4. Okay? So, in this example, it is 4, right? Because we have 4 elements that are in all of them. Let's consider number of elements that are in A1, S1, S2, S3 like this, A1, 2, 4, A1, 3, 4, A2, 3, 4, right? So in your example, A123 is what? Only in A123, not A1234, right? Elements that are in only these three subsets. So A123 in your example is what? Y3 can tell me which elements are exactly. This one, this one, this one. Because your example is symmetric, it's all of them will be 2, right? What about A12? Yeah, 0 in your example, right? So we have A1, A2, A1, A3, 0 to A 3, 4, right? And we don't need to check A1 because the problem says only focus on the AIs that are in at least 2 of them. So we should calculate minimum of what? Yes. Elements that are in all of them. Plus, yes. And we are not calculating anything twice, right? Last one, A3, 4. We should find minimum of this, right? And now my problem, the thing that we should focus on is to prove this one is at least what? Yes, if we prove this, then the problem will be solved for 4, right? For n 2 and 4, right? So let's try to prove this part. And let's apply the conditions. If t is 4, because it says 4 divides intersection of all of them, then we can say what can we say about these variables? T is a subset of S1 to S3, S4, right? Then 4 divides what? Exactly, A1, A2, 3. Or we can say A1, 2, 3, 4 is what mod what? Exactly. Now let's focus on, if I consider T3, then what can we conclude? No, 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 no. One of them is A123 plus A1, A234 finished, right? It is exactly S1, S2, S3. Agreed? So S1, S intersect S2, intersect S3. Do you agree? Some of these two variables. Next condition is 3 divides what? Exactly. Next one, 3 divides. Exactly. And last one. Yes. So we can conclude what? We can conclude all of them are 0 mod 3, right? But A1, A2, A3, A4 is equal to in all of them, right? It's same in all of them. So do you agree we can say these 4 variables are congruent mod 3? And all of them are congruent to negative A1, 2, 3, 4 mod. Agreed? Okay. We don't need to, for this example, we don't need to consider A1, 2. Because from here we can prove that we need at least 14 elements. At least 12 elements. So A1, 2, 3, 4, we know is 0 mod 4, right? So now let's consider A1, 2, 3, 4. The minimum of A1, 2, 3, 4 is what? Then what? No, no, no. This one, this one, A1, 2, 3, 4 can be 4 or 8 or 12, 16. From here, do you agree the problem will be solved because we want to prove at least 12, right? So we should focus only on these two cases, right? So can you tell me in this case, A1 to 3 would be what mod 4? Mod 3? 2 mod 3, exactly. And for this one, A1 to 3 would be what mod 3? Exactly. So if you consider these two cases, you can prove in each of them we have at least 12. We want to calculate what? We want to calculate this. Let's define this one as, for example, this one as t. For each of them, I can prove that t is at least 12. Want hint or want to try to prove this part on your own?
Wait, isn't it just because 1, 2, 3 would be greater than like
2 mod 3.
that
For this one, it is, for this one, A1 to 3 is at least what?
2?
2. And how many of these things do we have?
4.
4. 4 times 2, 8 times 4, at least 12, right? What about this case? Exactly. So for both cases, by this approach, we prove this, right? And this, the idea for this one was what we can say somehow double counting, or concept from different changing viewing angle. Instead of considering from SIs, we consider from A1 to 3 elements that are in all of them, in 3 of them, and so on, right? Okay, and this is, I can say, the difficulty of this problem is similar to PMO last problem, okay? It's not easy at all, but it's good. We tried it. With a small example, we checked 2 and 2, 2 and 4, right? Now in 2 and 6, we can find the idea because 2 and 6 is harder than 2 and 4. So let's check 2 and 6. In this case, we have what? S1, S2 to S6, right? Okay, so let me write all of them. Here, we want to see our answer is what. So like 4, you can try to find an example, and then we should try to prove it's at least what. Okay, want hint for 2 and 6 or want to try on your own? Okay, sure. Try for N6 and let me know if you wanted hint. Okay, sure. We want to find an answer. It's not important. It's best answer or not. Could you find any example? Okay, so for example, let me tell you an example for previous one. A2, A3, A4. Suppose that, sorry. If A2, suppose all A2, A3, 4, all of them, A2, 3, A2, 4, all of them are 0 except A2, 3, 4. Another example. So if A2, 3, 4 equals what, then the problem, the conditions will be satisfied. Why 24? 24 is good because then, yes, do you agree we can have these as 12 and all of them 0 means S1, S2, S3, S4? If we consider 1, 1, 1, 1 to 12, 12, 12, do you agree all conditions are satisfied? Because if you consider intersection of 3 of them, it's 12, which is multiple of 3. 2 of them, which is 12, which is multiple of 2. 4 of them is 12, which is multiple of 4, right? So by this approach, we can find what? We can find what by this approach we can find example with what they want. Yes. If it is 60, then it's somehow it's LCM of 6543, right? In previous one, it was LCM of 432, right? Which was 12. Okay, so from here, answer is at least 60 or at most 60. Okay, good job. Now, we think that the answer would be LCM always, but I think it was not. We can check it. But the key point here is when we wanted to prove why the answer is at least 60, we can find the whole idea of the problem, okay? Because it's a bit hard. The approach here that we want to use is similar to induction, but induction is from one variable to another variable, right? But sometimes we consider from a state or from a position to another position. It is not necessarily a variable, okay? I want to do what I say, okay. Suppose, for example, S1, S2, S3, S4, S5, S6. We have some elements that are in all of them, right? And these elements are multiple of what? Exact, 6 divides. I want to change them to something. Instead of 1 to 6, instead of 1 to 6, 3, 4, 5, 6, I want to, let me tell you. At first, suppose we have these. For example, for one subset, I cancel these and I cancel 6 of them, okay? I cancel 6 of them, I erase them, and then instead of that, let me write with same color. Instead of 6 of them, I cancel them and replace them with what? Replace them with 5 here. Because here we have 6 elements, let me explain for you for S1, S2, S3, S4, then you can understand it better, okay? So for S1, S2, S3, S4, we wanted to prove it's at least what? Answer is at least what? 12. Let me tell you the approach I want to tell you here. We know number of elements that are in 4 of them is multiple of 4, right? Now consider we want to erase these 4 and instead of them we want to replace them with this. This one, this one, this one, and what is next one? This one. Okay. So we remove 4 elements and again we add 4 elements. So number of elements won't change, right? So we remove, for example, suppose it's 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. I replace them with this 1, 1, 1, 2, 2, 2. Try to prove again all conditions would be satisfied if we remove this and add this. So you should prove what? You should prove again 4 divides S1, S2, S3, S4, right? 3 divides S1, S2, S3, right? And do you agree the thing we did here is symmetric with respect to S1, S2, S3, and S1, S2, S4? If you prove one of them, it will be solved, right? So suppose at first we have a good example, and then if we remove this and replace it with this one, again all conditions will be satisfied. This one. Okay? The first one is easy. Why if we remove this and add it with this, then this one will be satisfied again? Yes, maybe we have more than that, but we subtracted 4 from this, right? In the beginning, it was multiple of 4. If you subtract 4, again, it's multiple of 4, right? Why 3 divides S1 intersect S2 intersect S3? So this one delta was minus 4. That was the reason. Here delta is what? Exact, minus 4 plus 1. Do you agree again? It would be okay. What about this one? Exactly. So by this approach, do you agree again all conditions are satisfied? Okay, so we removed 4 elements and we added 4 elements. Do you agree we can remove it until S1 intersect S2 to S4 equals 0? Because it is multiple of 4. We subtract this by 4 by 4 by 4 and each time we replace with this. So now we can reach the case that S1 intersect S2 intersect S3 intersect S4 is 0, right? Then and we know then we should focus on 3 subsets, right? Again, do you agree if we consider these 3, it is multiple of 3 elements that are in only S1, S2, S3? Again, can you guess that we should replace them with what? Exactly, 1, 2, 1, 3, and 2, 3. Now again, we want to see that why it satisfies all conditions. So we should again consider 3 divides S1 or 3 divides S1, S2, S3. 3 divides S1 intersect S2. Sorry, 2 divides S1 intersect S2. Can you tell me delta here is what? So again, do you agree it would be good? Now, do you agree by this approach we reach a case that only we have A1, 2, A1, all of them except A1, 2, A1, 3 to A1, 4, all of them are 0? And do you agree they are not 0, right? Each of them should be at least 1. Agreed? Okay. So can you tell me, 2 divides S1 intersect S2. S1 intersect S2 is what in terms of AIs? Yes, because A1, 2, 3, all of them are 0, right? We change them to 0. So 2 divides A1. So how many pairs are there? 4 choose 2, 4 choose 2 times 2, which is 12, right? And for 6, if we use same approach, we reach what? 6 choose 2 times? 6 choose 2 times? So, yes, S1, let's check S3, S4, S5, S6. Let's check this. We should keep working until 3, right? Because half of that. Agreed? So it will be what choose what times what? Times what? Yes, which is what? So because we have elements that are in at least half of them, right? Okay, because if you change it to this, we want to find minimum of this, right? Plus the rest, A1, 2, 3, right? For this one, A1, 2 is not important. Agreed? For the problem, it says only the elements that are in half of. So now we want to generalize. Now we found an approach. And can you tell me for 2n we should prove what by this approach? Answer is at least what?
Um,
Exactly. Try to use same approach for 2n to prove answer is at least this. Then we try to find an example. Okay. Okay. Try to prove this part. One thing for proving this part, or want to try on your own? Okay, sure. Try. One hint, or want to keep trying? Okay, sure. So let's apply same approach. Okay. And step by step, we want to prove that's good. So, if we want to do it for, let me open some pages. Suppose we have S1, S2 to SM, okay? To S2N, Sn plus 1 to S2N, okay? So first, we have some elements that are in all of them, right? And it is multiple of M, right? In multiple of 2n. In each step, we want to replace each 2n of them to what? Exactly. Exactly. Let me, if we write like this, then we want to change it to all these elements. This one, not this one. This one, not this one. This one, right? To last part, not this one, this one. Now we want to see if we replace it, all divisibility conditions are satisfied again, okay? So we erase it and we place this. So let's see what happens. We want to see S1, S2 to S. What happens for this? What happens for S1, S2 to S2n minus 1, right? What happens for S1, S2 to S2n minus 2 to what happens to S1? Do you agree we don't need to consider, for example, if we want to consider k of them, we don't need to consider all k's. If we check this one, do you agree all of them will be similar? Because when you change this, you consider all to n minus 1 subsets. So if S1 to Sk be satisfied, all other k subsets also will be satisfied. Agreed? Okay, let's see for each of them delta would be what? For the first one, delta would be what? Exactly, minus 2n finish. And we know 2n should divide this, and that's okay, right? What about this one, delta for this one? They agree it's good because we know 2n minus 1 divides this, right? What about this one? Plus, exactly, 2. Again, we know 2n minus 2 should divide this, right? And what about general k, S1 to Sk? Good job. Because always we miss one number, right? One element. And that element should be outside that. Because outside that we have 2n minus k subsets, we have 2n minus k cases to miss which of them, right? And they agree it would be minus k. And we know k divides this, so it would all conditions will be satisfied again, right?
Right.
Okay, so do you agree exactly by same approach? For example, suppose in the middle we have S1, S2, S3 to SM. And suppose we removed all elements that are in more than Sm plus 1, right? In more than M subsets, okay? So now here we have m. It is multiple of m, right? So we consider m of that, and then we replace it. For each m of them, we do the same thing. So here we replace it again with this one, with this one, right? To this one. Now we want to check all our conditions satisfied or not. So we know that m should divide S1 intersect S2 to Sm, right? M minus 1 should divide S1, S2 to Sm minus 1, number of elements. Then again here we can say K should divide S1 to Sk. And here also we should throw these, we should place this to means number of elements. To show there are number of elements. So here until 2. So again, with exactly same approach, we can prove this. Can you tell me for first one delta is what? Exactly. What about second one? Which is good for this one, for K. Yes, so all of them will be satisfied, right? So now do you agree if we keep going to reach only n subsets, okay? S1, S2 to S2n. Suppose Sn, Sn plus 1. Suppose we have only elements that are S1, S2 to Sn, okay, and so on. So can you tell me answer would be what at least? What divides S1 to Sn? Exactly. N divides this. So do you agree? So we can conclude S1 to Sn is at least what? But why it is not 0? If we prove this, do you agree then we can say at least n times 2n choose n, right? Okay, so how can we say that it is not 0? If we prove it is not 0, do you agree this proof will be complete? Okay, and want hint for this part that is not 0, or want to prove it on your own?
Let's just try.
Okay, pay attention. In assumption of the problem, it says what is not 0?
Intersection.
Intersection of? No. Intersection of all of them is not null set, okay? It says whose intersection is non-empty, this part. Okay? So we know S1 in the beginning, S1 to S2n is not 0, right? It's not null set. So now we want to prove why it is not 0. Okay? So in the beginning, S1 intersect to S2n is not null set. Okay. So try to prove why it's not 0, okay?
Oh, is it just because if
Yes, we can say because here is not null set, we have some elements, right? And because we have some elements, then if we consider first step to if we consider each two on n minus one subsets, it won't be null set, right? Because after removing these, we will give some elements to each of them, right? Then we can say, okay, by moving in next step, for example, suppose by induction, these M subsets have some number of elements, non-zero number of elements. Then we move to each of M minus 1 subsets, some elements. So again, M minus 1 subsets, if we consider their intersection, cannot be null set, and so on like this to reach S1 to Sn, right? Understood, or want me to explain it again? Okay. Okay, so look, at first we know S1, S2 to S2n is not null set. Then we said what? We said, okay, in the beginning. Then we said, okay, if we consider S1 to S2n, so we subtract some elements. So when we subtract some elements, we consider for each S1 to S2n minus 1, we consider one element for this. We consider for another one element, right? So now after this step, do you agree if we consider 2n minus 1 subset, it is not null set because of this? Then after this, in next step, you can say if you consider any 2n minus 1 subset, it is not null set. What?
Then probably you'll reach like
Yes, yes. After some number of steps, it will be 0. But in the beginning, it's not 0, right? In the beginning, it's not 0. But after, then we make it null set, right? By subtracting. Then these things are not 0, right? Then we keep subtracting from these things. Then S1, S2, S2n minus 2, we can say is not 0 because when we subtract elements from here, we are adding elements to these subsets, right? Then you keep writing like this, and then you can say, okay, S1 to Sn is not null set, right? So we prove this at least n, and we prove this part, right? Okay, so now for n3, now we need to only find example, right? For n3, 3 times 6 to 3, 60, right? We prove this one. And so we can find an example with 60, all of them, each of them has 60 elements, right? And the condition would be satisfied, right? Okay, so for n3, we proved the problem, right? If it is n4, then we have 8 subsets. S1, S2, S3, S4, S5, S6, S7, S8, right? But the thing we prove, we can say answer is at least what? A choose 4. 4 times 8, 7, 6, 5 over what? Over 4 factorial. Yes, this, 6, 6, 280, right? Now try to find an example with 280, okay? One thing for finding example with 280, or want to prove it on your own? Okay, sure, try. For example, find one hint or want to keep trying? Sure, so here, because N4 is a bit large, and sometimes, as I said before, proof helps you to find example. Sometimes example helps you to find the proof, okay? And as you saw, we considered, for example, the elements symmetric with respect to S1 to, for example, S2, right? When we wanted to add, we added, for example, like this, symmetric with respect to them. So let's see if, for example, we want to do same thing for S1, S2, S3, S4, what happens? So I want to have some number of elements like this. I want to have some number of elements in 3 of them, some number of elements in 2 of them, okay? For 4, the answer was what? Oh, so these elements should be multiple of 4. This plus this should be multiple of 3, right? So, for example, if you consider 4 elements here, let's consider exactly 4. Then here we should have how many of these things? Yes, we can have 1. Let's see what happens. And what about this one? Let's check. S1, S2, S. Okay, so like 1, 1, 1, 1, 2, 2, 2, 2, 4 threes, 4 fours, okay? Then I can say 3 of them. 1, 1, 1, 2, 2, 2, right? 3, 3, 3, 4, 4, 4, right? And then what? Okay, so let's see. Do you agree 3 of them, 4 of them would be okay, right? 3 of them, 3 of them won't be okay. We need 2 from each of them, right? Agreed? To be multiple of 3. So let's write 1, 1, 1, 2, 2, 2, then 3, 3, 3, 4. And here, so it's better. So this one is not equal to this one, okay? It is again from next part, so it would be 4, 4, 4, then 5, 5, 5, 6, 6, 6, and 7, 7, 7, 8, 8, 8, right? So here the agree is if you consider 3 elements like S1, S2, S3, it's 6. For 4 elements 4, and for 2 elements if you consider this part 6, 7, 8, it's okay, right? So for 4 choose 4 we have 1 and we have 4 elements. For 4 choose 3 we have 2 elements, right? So it was 4 plus 8, 12, right? Now, if we want to use same approach for 6, the answer was what? Uh, yes, n times 2n choose n, right? The answer we know is 60. If we want to use same approach, we should see how many elements do we have like this. How many can you guess? Then how many in S2, S3, S4, S5? Then how many? So let me write like this. How many elements are in all of them? How many elements are in 5 of them? How many elements in 4 of them? How many elements in 3 of them? Can you guess we should consider how many for this part? For S1, S2, S3, S4, we did what? 4 and 2, right? 4 of this type, 2 of this type, right? Okay. So how many elements are there in all of them? Yes. What about this part? If it is 3, then if you consider this 4, exact. What about this one? What about this one? Yes. Now we should prove 2 things. So let's add all of them. So it would be what? 6 times 6 choose 6, right? Plus 4 times what? Plus 4 times what? So the first one is what? This one is what? Plus what? Which is what? Okay, now we want to generalize this. And how can we prove that this example is good? Exactly. If I consider 6 of them, it's good. 6 divides 6, and then 5 divides 6 plus 4, right? And 4 divides what? 6 plus 4 plus 2, right? And 3 divides 6 plus 4 plus 2, right? And can we say because the problem says for all subsets it would be good. So for 2 also, do you agree it should divide this? So this one is okay, this one is okay, 6 plus 4, 12 is okay. This one is okay, this one is okay, right? Now we want to generalize this one. Want to generalize it for 2n or for 8 first? Okay, want hint for generalizing for 2n or want to do it on your own? Okay, sure, try. Want hint or want to keep trying?
Generally, 2n minus k is 2n times 2k, and then you can prove that it does divide.
So let me check. For S1, if we consider S1, S2 to S2n, how many elements are in all of them? What about how many elements in 2n minus 1 of them? And how many elements in k of them? Which k is greater, let's consider as k, which k is at least 2n. How many elements are in k of them?
Minus k.
2 times 2n minus k, you said? So it's 2k minus 2n, right? So 4n minus this, 4n, exactly. 2k minus 2n until you can say for Sn. For Sn is 2n minus 2n, which is 0, right? It is for S1 to Sn. For next one, S1 to Sn plus 1 is 2, right? So we should prove two things. Why the conditions are satisfied. Why the conditions are satisfied. Let's check. For example, S1 to Si. Why? So this one would be what? Suppose I is at least n. Okay, let's prove I at least n. Then we prove it's 2i minus 2n times what? Choose what? Mm, let me check. No. 2i minus 2n only. Okay. Sorry. Plus what? 2i plus 2 minus 2n, but times something. Because look, this one is only for S1 to Si, right? But do you agree next part you should consider S1 to Si, Si plus 1, S1 to Si, Si plus 2, right? To S1 to Si to S2n, right? So it would be what? Choose what? 2n minus I. 2n minus I choose 1, right? because from 2n I plus 1 to 2n, we should select one of them. 2n minus I choose 1. Agreed? Next one is what? Plus
2i
times what? Choose what?
2n.
Exactly. Until last part is what? What choose what? 2n minus I, right? Now you should simplify this. Want hint for simplifying this part or want to do it on your own? Okay, sure. Try to simplify and find it in terms of I, okay? Want hint or wanna keep trying?
can you give him?
Sure. So, let's see how can we simplify this. Let's write it as sigma, okay? So it would be sigma what? Mm-hmm. K is from what to what? No. Let me think. Yes, yes, yes. And what choose what? Exact. Now let's simplify this, okay? Here, can you tell me we can write R times and choose R as what? Why? Yes, and select one of them as captain or captain first, team, rest of the team, or team first, then captain, right? So, here, that we have 2i, right? And here, I is constant, okay? So we should work on k. So, you can write it as 2i minus 2n sigma k0 to 2n minus I. 2n minus I choose k plus 2 sigma k times 2n minus I choose k k0 to 2n minus I, right? Okay, now this sigma is what? Good job. 2 raised to 2n minus I. Instead of this, we can write what? Yes. And k from what to what? Yes, because when k is 0, it's 0. It's not important. You can write 1 to not have negative 1 here. To what? Yes. So it would be this 2n minus I plus 1 2 times. You can factor from 2n minus I, so this would be what? Good job. Now we can factor from what from both sides? So it would be what? I minus, yes, 2i minus 2n plus 2n minus I, right? So it would be cancelled. It is I times 2 to the n minus I. We wanted that this one be multiple of I, right? And it is multiple of I, right? But we consider these for I at least n, right? If I is less than n, what should we do? We can make that one okay without any calculation. If I is less than n, want me to tell you how you can make it okay or want to prove it on your own? Okay, sure. So if I is less than n, for example, I is, for example, 3. You can consider, for example, let's start from I n minus 1, okay? Then you can consider each n minus 1 of them and see, okay, how many elements it needs, then add those number of elements, and we won't calculate it in our answer. Because our answer is what? Our answer is only we should calculate elements that are in at least n of them, right? So for example, you can say S1, S2 to S minus 1. You need, okay, you see that, okay, you need 4 elements. You can add 4 elements. And then, do you agree it has no effect on S1 to Sn or greater ones? Let me, if it is hard, let me tell you an example. For example, look, S1, S2, S3, S4, S5, S6, okay? So suppose we find an example that makes 6 of them okay, 5 of them okay, 4 of them okay, 3 of them okay, okay? Then for 2 of them, you see, okay, S1, S2, they have how many elements? For example, suppose we have 9 elements, okay? Then you add one more element to make it okay, okay? Then you can say S1 and S3. Okay, it needs how many you add S1, S3? Well, for example, if it is 10, you don't need to add. If it is, for example, 7, you should add one element. Then by this way, you can correct 2 elements, right? And it has no effect on our answer, right? So the conditions that are related to less than 3 are not important for us. Understood? If it is a bit hard to understand, if it is a bit hard to understand, understood completely how you should make it okay, or want me to explain more?
Could you explain?
Okay. So again, for S1 to S8, by this sigma, we prove that for 8 it is okay, for 7 S's are okay, 6 okay, 5 okay, until 4, right? Okay. Now I say, okay, suppose we have these 3 elements. For example, we want to check why 3 elements are good. So do you agree when you make all of them correct, for example, intersection of these 3 is a number, right? Do you agree, for example, intersection of them is 4, okay? Or for example, it is, for example, 34, okay? Then I add 2 elements to these 3. Do you agree these 3 will be okay? Then intersection of these 3 will be 36 multiple of 3, right? So these 3 will be okay. And do you agree it has no effect on these parts? So again, consider S1, S2, S4. If they need some number of elements, add, for example, this one, this one, this one. So do you agree by this way we can make 3 subsets okay? Now consider 2 subsets, for example, S1, S2. It should be even. Suppose, for example, this one is 65, for example. So we can add one element to S1 and S2. So, and do you agree it has no effect on these cases? So do you agree by this way we can correct two subsets? Agreed. For you consider each two of them and you add any as you add some number of elements to make them correct. Okay. Then do you agree by this approach? These things has no effect on our answer, right? Because in our answer we only consider elements that are in at least four of them, right?
Right.
So we should focus only on 8 to 4. Understood now why we should only focus on n subsets to n subsets? Okay, because again, you consider 2n to n. By the sigma, we proved all of them are okay. For n minus 1, you consider each n minus 1 subsets and add as much as you want to make them correct, okay? Okay, and then n minus 1. Okay, n minus 1 has no effect on these things. Then you should correct n minus 2 to 2, okay? And these things has no effect on our answers. Any question about this part? Okay, now we should focus on one more part. We should prove that y sum of all of them is equal to n times 2n choose 2, right? 2n choose n. Agreed? And the proof is similar to this part. For S1 to Si, do you agree we proved? It is exactly this. For S1 to Si, we proved this, right? So, if we want to, here we should consider number of elements. So, number of elements is what? Can you tell me? There's 2n for all of them, 2n. Plus 2n minus 2 for each 2n minus 1 subsets. So 2n minus 2 times what? What choose what?
Well, choose one.
Exactly, 2n choose 1. Next one is what?
Um, two.
2n choose 2. Yes. And last part is 2 times what choose what? Let's check. I am thinking of something. No. Let's say something. You can say 2n choose 1 or you can say 2n choose 2n minus 1, right? Because we have 2n minus 1 subsets. We want to select 2n minus 1 subsets from 2n subsets. So it's 2n choose 2n minus 1, right? And, next one you can say 2n minus 2, right? And last one, 2. How many n subsets are there from S1 to S2n? 2n choose what? For here it's 0. So here for this one, 2n choose n minus 1 or 2n choose n plus 1, right? Both of them are the same. We want to prove it is equal to what?
Choose one times one.
Exactly. If we prove this, the problem will be solved completely, right?
Right.
Want hint for proving this part or want to prove it on your own? Okay, sure, try.
I'm actually not sure if I'm gonna get it.
Okay, so let's try this. Again, we want to use this formula that we said R times n choose R is this, okay? So let's see. And when you want to calculate, let's check for example for 3 to make sure not have careless mistake, okay? So it's 6 times 4 times 6 choose 5 plus 2 times 6 choose 4, right? Which is 6 plus 4 times 6, 24 plus 30, 60, right? Which is 3 times 6 choose 3. Okay, let's prove this. We know that if this one is equal to this one, we can use that formula, right? So we can do something. What's the relationship between this and this? It is 2 more than that. If we consider 2 and choose 1, what happens? 2 and choose 1, 2 and choose 2. 2 and choose n minus 1, right? So let's write also first one. Let's write as sigma. And we can write first one as 2n times what choose what? So how can we write it as sigma? 2n minus 2k times what? 2n choose. In case from what to what? Exactly. Now we like that this one equal to this one, right? But because we have minus 2k, so if it is 4n minus 2k, then it's good, right? So we can split this to 2 parts. 4n minus 2k times 2n choose 2n minus k plus what? Exact. Negative 2n times what? Exactly. N minus k. Sorry, n minus, it was n minus 1. Minus 2n times 2n, choose 2n minus k, right? Okay, now we can write first part, we can say this one is equal to what? K0 n minus 1 minus 2n sigma k0 to n minus 1 2n choose 2n minus k, right? And then you can factor also this one, you can write it as a 4n, right? 4n sigma k0 to n minus 1 2n minus 1 to n minus k minus 1, right? Minus this word. Then we should simplify this, right? Want hint for this word or want to try it on your own? Okay, sure.
Okay, I think I got it. The first part is 4n times.
2 raised to 2n minus 1.
Let's write. The first part is what? 4n times?
2 raised to 2n minus 1.
Let's check. If you replace with 0, it is 2n minus 1, choose 2n minus 1. Right? If you replace k with 1, it would be what? If you replace k with n minus 1, it would be what? Exact. And this part would be what? Exactly. Because we have 2n minus 2n terms. Here we have n of them, right? Half of them, and we know n 2n minus 1 choose n is equal to 2n minus 1 choose n minus 1, right? Next part would be what? Minus 2n. If k is 0, it would be what? 2n choose 2n, right? Because 2n choose 2n minus 1. To what? 2n choose n plus 1. Then what? So let's check. 2 raised to 2n is all of them, right? So you should subtract 2n choose n and then divide it by 2, right? So it would be what? 4n times this is n times 2 to the what? Yes, this to this 2 would be cancelled. So minus what? Minus n times 2 to the 2n, right? And then plus what? Yes. These two terms will cancel each other out, and n times 2 to the n, choose n, will be left, right? Okay, so understood completely how we solve this problem, examples and calculations? Okay, we considered the small examples, right? And n2 and 3, it was a hard problem. And then after that, we found some idea in 6. Then we use this to change from a state to another state, right? From a position to another position and reach the answer. Okay? Any question? Okay, so have a good night. Thanks. Bye.